Hello everybody. Today I'm going to make a video about the second project of the part 3. In this one, we are going to read a signal, analog signal from a temperature sensor, LM35, which you see the picture here. And we will show this number, whatever it is, in the LCD. Liquid alphanumeric LCD it's called, and you will write it ALCD in the everywhere. I will mention it with the ALCD. Here first you're seeing a picture how it's installed. For this just here in behind these wires is the LM35. There is a resistor for limiting current for the background light. And there is this adjustment potentiometer for the adjustment of the brightness of the LEDs that are showing the number, like contrast, adjustment of contrast. So this is what you will make in the class for the second project, and then let's see what. The first part, let's say about the LCD, what pins it has, and how we will connect it. This drawing is showing basically the potentiometer, which is connected to the ground, VCC, and in our LCD there's a pin V0 instead of VEE. So you will connect as this picture shows, and with the adjustment of this you will adjust the contrast of the characters here. These three wires that you see, C0, C1, and C2, are called control signals that we will send to them. And the data will be sent through these four wires that are here. So if we are, let's see, in this table you can see what is each pin on the LCD, meaning first pin from the left, you can see the 1 through 14. The first pin is the ground pin, second VCC or 5 volt. Third one is V0, which is for adjustment of the contrast. The fourth pin is the register selected. With toggling it, you can decide that you want to send a command signal or data signal. There read and write that controls if you want to read or write, read or write operation. Enable must be held high to perform read write operation. So enable also is being controlled by the program, but this part will be done all by the code wizard. The C programming language takes care of it on its own, so we will not need to worry about the details here. We will use a 4-wire connection, so the pins 0 to 3 we have to connect. The data pins we will connect to 4, 5, 6, 7 to the pins of the port C. All the wires here will be connected to the port C, and let's see, and there is this background light also, that there's these two pins, BLA and BLK. Cathode is for the negative and anode is for the positive. So that you can connect it, you should use a resistor for the current limiting. I think there's nothing more here to know. This is how you will connect. This is our port C in our microcontroller. And this is the calculations. What is the signal that we will get from the temperature sensor? LM35 is the sensor. It will give it can measure temperature from 2 to 150 Celsius, and for every Celsius if it's 2 Celsius, it will give us 0 millivolt. And after that, every like 1 degree that temperature is raising, it will add 10 millivolt to it. And so it's not very precise sensor, so it will give you the value. Basically, if you have a 5 volt network that you are giving 5 volt power to it, it will give you an output of 0 to 1.5 volt about, and this range will represent 2 to 150 temperature degrees. So for conversion, we have to like convert in our analog signal. When we have decided that we are using 8-bit resolution, and we have 0 to 5 volt. When we are getting 0 volt, analog to digital converter will convert this 0 volt to the 0 integer number. But when we are getting 5 volt, it will convert it to 255 volt integer number. So when we are getting 0, it will give 0. When we are getting 1.5 volt, it will be equivalent to something like about 76.5 value. So if we make it integer, it will be 76. And it is calculated like this: 1.5 divided by 5 multiplied by 255. It's just converting the range. Like if it was 0 to 5 volt, it would be 0 to 255. In this range, what will be a 1.5 volt value? If you calculate, you reach to this number, 76. And so based on this, our temperature range is this, and the number that we will receive from analog to digital converter pin will be this: 0 to 76.5, 76. So it's integer. So for calculating temperature, we have to say temperature ADC is this number that we will get from the analog to digital converter pin. We have to multiply it first we multiply it by this range, that is 148, and then divide it with the 76. This way we can calculate the temperature based on the signal that we will receive from the analog reader. And the pinout that you can see here, it is for the LM35DZ. So it's a bit different than the LM35 that we have. Or LM35, we have DZ, I guess. Yeah, we have DZ. So the pinout just ground is in the right side, V out is in the middle. This is all about this. Next picture. Okay, pictures are finished. What is our task? Reading analog sensor and showing it a value in the alphanumeric LCD. Alphanumeric liquid crystal LCD. Here we will connect the LCD to the A1 pin. Yeah, this is important. We should remember A1 pin in the, so that when we are configuring, we will put this, we will mark this where we are connecting. The signal value sent from the LM35 will be displayed at the LCD. Second part will be see how we can create array of the characters using basically in our code is in this practice we are seeing how the array of the characters are built also. So let's take a look at the code right now. Here's just the name, what frequency is the CPU is working at, at Mega32A library. stdlib is this library that is used when you wanna convert integer to the string. or vice versa, you have to use this library functions. Delays needed for the stdlib for using the analog digital. Delays needed for analog to digital converter function. And ALCD.h also is a library that for like reading the alphanumeric LCD function. So this LCD has its own library. We don't have to go write the pin on like the code on our own. There's a library that CodeWizard will add for us, and we can use it. Here I have this defined like one integer I that to use in the for loop and so on. There's a char like that is data type is char, and it has 8 items in it. And next one is char that has 8 one. I put just like when you activate the analog to digital converter in the CodeWizard, it will create this function for you. This is basically the register that turns on. This is giving the configuration that analog to digital converter will be active, and this is the function for it that let's see. This is the function that it will make for you. You just have to give this one pin number, ADC pin, and read ADC pin number, and it will return to you AD character like ADC. Some value it will give you, and it will be this value will be from 0 to 255 depending on what voltage is on the analog pin that we have. Okay, this one I cannot clear. Yeah, I could clear. So let me mark it again. This is the analog to ADC analog to digital converter reader function that is automatically made. We will use it, and this is the value that it will give us. We give we call this function with the pin number that we are connecting the LM35 output to a analog pin 1. A1, so we will call it read ADC1, and it will go read it and then give us an integer value of AD chair. So the rest of things are just you should know now that they are configuration of the ports. Then there is, let's see what is the port A configuration. This is port A. Everything is input, everything, there's no change in the port A, everything is in the tri-state mode. And yeah, so yes, here also nothing. Port C bit. This is automatically created, so we don't have to do anything with them. We just add here LCD clear, so that at the beginning of the code, this LCD will be cleared. This 16 says how much is the length of like our LED is 16 times 2. So we have to put, this is the 16 in the X direction, how many LEDs we have in our LCD. We have 16. That's determined here. LCD clear clears the LCD. It's a function that is in this library. Next, we have to go to the, again, in the while loop at the top of the code, we are clearing the LCD. we read the pin 1 and save it in the value in the I. Then we write this like string of the like text, a string of characters in the LCD. So this will write temp is space. We make a delay, then integer to array function. We have the I is an integer number. We cannot show it directly in the LCD, so we have to use this function with this syntax. We give the integer, and we had a defined character of eight like items. LCD puts then we so this I to A function reads the integer value and turns it into the character and saves it in this array. Then we can use this command LCD puts to show this in the LCD. LCD puts, again, we will put this unit for the temperature also. So, and the delay millisecond. This is the delays are so that this cycle doesn't go very fast. It's just making it like going with going a bit slower. This is all we need for the like this part only. Is all we need that we want to read the analog pin and show it on the LCD. We haven't done conversion that can be added, but right now it is just a raw number. The number that's reading sends it to the LCD. The second part, if we ignore entire this upper part, we can see this is like while loop, and here we clears LCD. You remember the J1 that we had? Now we give to every index of it, and we give a number. I just wanted to show what happens if you give this number. The program thinks you are giving the ASCII table code for the character. So it will not put the 84 here. It will go to the ASCII table and see which character. Is it T? Is it whatever? The ASCII table, you remember what it is. So it goes there, sees that as 84 is the code for T, and puts it in the first space in the array. Then next space, E, T, different codes, different, like space is 32. This colon is 58, and again, space you put there. If after you can use this command to LCD puts to show this array of the characters inside the LCD, and it will show something like this inside the quotations, not quotations themselves, just inside temp space semicolon space. This is what it will be there. And then display delay millisecond. This is just delay for the update we put there. If we make I, for example, 35, we have to like change like this, and then this is first we have to do in the course for the test to see if our LCD is connected and working correctly. Then we will read the I from the pin. So we will put in the beginning we will put a value 35 to the I, and then show it in the LCD with this command. This is all about the code, and I will just quickly show how you will activate the LCD and some explanation about the LCD. Let me go here. So it's loading there for connecting the LCD. For connecting LCD, you need to give the type of the LCD. let's close this all. And I will make a new project. Here I will, it's coming, the wizard. I will explain what is going to be selected here. So let's selector at mega 32, 32A. Please pay attention that 32A is not 32. They are a bit different. Some functionalities are added here that they don't have here. So you should select exactly the A. The megahertz is that we want to, let's go and activate here in the menu. You can see there's alphanumeric LCD. Enable it. And here we will decide to which port we have to connect. Port A is for reading analog signals. We cannot connect this to the port A because we want to use port A for the reading analog signals. So we are selecting this to be port B, port C. Let's make all of them port C. And let's see. We could choose B or D, for example, but port C I use just to use them. RS, these are the pins that were in the, what is this? These pins that are here. You can see RS, RW, E, D4, D5, D6, and D7. These are these pins that we select where we will connect them in the port C. So RS will be to C0, RW will be to C1, E to C2, C3, nothing is connected. D4 is to C4 and so on. And here, let me close this. Yeah, here you can see RS is to the port C, bit 0. This is the same order. Enable to the second pin, then D4, D5, D6, D7. This is the controller type of the or LCD. It could be different. If like sometime you might have different type of the LCD that what we have. You should choose the correct controller type here. And we have the characters in the line. We have 16. So you can see there's you can have different sizes of the LCDs. We have 16 times 2, 16 in the like horizontal direction and 2 rows we have. So here this is set, everything, ports we don't have to do anything. So we just say program, let me see, analog, no, this is just the alphanumeric LCD. We haven't activated the analog to digital not this. Analog to digital converter. Here we have to activate this also. So here by default it's using 10-bit configuration, which is 1024. But we don't want to use that. We want to use 8-bit. So you click here to so that we can use the 8-bit configuration or the reading number would be 0 to 255. Interrupt. We don't need like the reference pin that we want to have because you need to give a reference pin for the analog signal. You can give it some output signal that you have, or you can select that your VCC, that 5 volt that you have, this would be reference, or internal 2.5 reference. Also, there is different references that right now we just use the VCC. So here you select, I want my 5 volt VCC to be the reference also. And auto trigger, we don't, yeah, software. How it should be triggered to go every time read the analog signal from the pin, you put software. In the software, we go with the read ADC function, we go read it. So here, this is all the setup that you need. The clock hertz for the ADC we can select also. It's like the same as Prescaler. You want how much it be, how much its working speed to be, but we don't need to change it. 1 is enough. Generate, save, and exit. And then here, let's see. I will give let's put it in the desktop. Right. Oh, sorry. Desktop. New folder. LM35 is the temperature sensor. LM35 I put here. Again, it will pop up another window. LM35. One more time. LM35. And it built the code for us. So stdlib is not here already. We will add it. Control C. stdlib is for converting the integer to the array of like characters. Delays include ALCD. This is for the LCD. Then you have this function read. Yeah, this is made by when you activated the analog to digital converter. With this configuration of these are the registers, like the bits in the register. With setting these 3 pins, we decide that our reference should be A, B, C, C. And this is the range. We have it 8-bit set, so this is the formula when it's given how read voltage will be. Like the voltage divided by ADC voltage times voltage reference divided by 256. What else we have? This is how it works. We don't need to explain or study it. We just know that it will give us a ADCH value. It's just a variable name. It will give us an integer. That's all. And then we go here and yeah, here we can write LCD clear. You see it suggests me because I have the library there. It will just yeah. And this will clear the LCD and whatever is inside, and then we will write our codes here. Okay, I think this project should be very simple. Just we should be careful when connecting all of those pins and defining all of them. Yeah, we have to be careful. And this capacitor that you can see here, it's added, it's 100 microfarad. That is for stabilizing the input voltage for the LCD. And so there is nothing else to say here. Okay, thanks, bye.